Chapter 4 begins our discussion on triangles. We're going to take the first couple lessons in Chapter 4 and review different types of triangles and properties of triangles, and then we'll move into talking about what makes triangles congruent, proofs, and additional properties. Okay. Chapter 4, Lesson 1 is classifying triangles. Okay, we can classify triangles into three different ways by sides and 3 different ways by angles, and every triangle can be classified by both sides and angles. Okay, beginning with classifying triangles by its sides. Okay, there are 3 different types of triangles based on its sides. Equilateral triangles have 3 congruent sides. Isosceles triangles has at least 2 congruent sides. And scalene triangles have no congruent sides. Okay, we have pictures of each of those below as well. Okay, our equilateral triangle with 3 congruent sides has a triangle, and notice there is one single hash mark on each of the 3 sides showing that those 3 sides are congruent to each other. An isosceles triangle, we have marks on 2 sides. Now notice in the scalene triangle, there's a different number of hash marks on each of the 3 sides, showing that each side is not congruent to the other. We can also classify triangles by angles. Okay? An acute triangle has 3 acute angles. Now, a special type of acute triangle is called an equiangular triangle. An equiangular triangle is a triangle with 3 congruent angles, all of which are 60 degrees. Since all of those degree measures are less than 90, this does also represent an acute triangle. An obtuse triangle has 1 obtuse angle, and a right triangle has 1 right angle. Okay. Now let's look at 2 of our triangles in a little bit more detail, the isosceles triangle and the equilateral triangle. An isosceles triangle is a triangle with at least 2 congruent sides. We call the congruent sides the legs. Okay. The non-congruent side is called the base. Okay. All triangles have 3 angles. In an isosceles triangle, the 2 angles across from the congruent sides are also congruent, and we call those the base angles. Okay. The angle between the 2 congruent sides is called the vertex angle. So in an isosceles triangle, we have 2 congruent legs and 2 congruent base angles. An equilateral triangle is a triangle with 3 congruent sides, all marked with 1 hash mark. But an equilateral triangle is also equiangular in that it has 3 congruent angles. Since the sum of the angles of a triangle is 180, divide that by 3, and that makes each congruent angle 60 degrees. Now we're going to take this information and we're going to identify or classify triangles with some specific information given. All right, so go ahead and turn the page. Okay, here's some practice for lesson 4.1 and some of the different types of problems we could see. Problem number 1, classify triangle LMN as acute, equiangular, obtuse, or right. So we're classifying the triangle based on its angles. Now, we are asked to classify triangle LMN. Okay, now I'm going to highlight that triangle. L, 2M, 2N is the entire figure. Okay. Angle L is 45 degrees. Angle N is 59 degrees. Angle M can be found by adding 45 and 31. Okay, if I add 45 and 31, I get 76 degrees. So the measure of angle M is 76 degrees. Okay, this represents an acute triangle because all 3 angles are acute, less than 90 degrees. So when I'm looking at definitions and theorem to help me solve the problem, okay, I know the following. This is a definition. Okay, an acute triangle is a triangle with three acute angles. Since my triangle LMN has three acute angles, this represents an acute triangle. Okay, problem number 2 says find x and the length of each side if triangle FGH is an equilateral triangle. Okay, now first of all, I'm told that triangle FGH is an equilateral triangle. Okay, well that's one of my definitions, so I'm going to put that out to the side. Okay, an equilateral triangle is a triangle with all sides congruent. Okay, so in my picture, I know that the length of FG is equal to the length of GH is equal to the length of FH. Now, I need to find X and the length of each side. Okay. Now, since all three sides are congruent, to find X, I'm going to pick two sides and set the expressions equal to each other. So I'm going to write that off to the side. So I'm going to pick two sides and set the expressions equal to each other. Okay. After I pick two sides and set the expressions equal to each other, I will solve for X. It does not matter which two sides I pick because the three of them are all congruent. So I will choose 3x plus 10 and 5x minus 8. So I'm going to set 3x plus 10 equal to 5x minus 8. I'm going to solve the equation for x. I can subtract 3x from both sides. So I have 10 is equal to 2x minus 8. Next, I can add 8 to both sides. So I have 18 is equal to 2x. Then I can divide both sides by 2, and x is equal to 9. Now that I have found x, I'm going to find the length of each side. So for the bottom, it's 4x plus 1. Since x is 9, I'm going to substitute. I have 4 times 9 plus 1. 4 times 9 is 36. 36 plus 1 is 37. Now, since this is an equilateral triangle, all sides should be 37. If not, I probably made a mistake in solving my equation. I'm going to go ahead and plug it in and just double check my work. So 5x minus 8 is 5 times 9 minus 8. 5 times 9 is 45. 45 minus 8 is also 37. Okay, and then the left side, I have 3 times 9 plus 10. 3 times 9 is 27. 27 plus 10 is 37. Okay, last problem. Find x and the length of each side if triangle ABC is an isosceles triangle with segment AB congruent to segment BC. Okay. Now, we're told the triangle ABC is an isosceles triangle. An isosceles triangle is a triangle with at least two congruent sides. I'm going to write that down in my definitions. So isosceles triangle is a triangle with at least two congruent sides. Now, in my picture, I'm told that my congruent sides are segment AB and segment BC. With this information, I need to find x and the length of each side. Okay, well, similar to the previous problem, to find x, I'm going to take the two sides that are congruent to each other and set the expressions equal. Okay, so I'm going to take the two congruent sides and set their expressions equal. After I set the expressions equal to each other, I will solve for x. Okay, so my two congruent sides are 4x minus 3 and 2x plus 5. So I'm going to set those expressions equal to each other. I can subtract 2x from both sides. Okay, 4x minus 2x is 2x. Bring down the minus 3. And then that's equal to 5. I can add 3 to both sides. 2x is equal to 8. And I can divide both sides by 2, and x is equal to 4. Okay. Now I'm going to take x and find the length of each side. So I'm going to substitute x with 4. So this is 4 times 4 minus 3. 4 times 4 is 16. 16 minus 3 is 13. Okay. Now these sides are congruent, so I need to check this also equals 13. So I have 2 times 4 plus 5. 2 times 4 is 8. 8 plus 5 is 13. And here I have 4 plus 2. 4 plus 2 is equal to 6. This side is not congruent to the other, so it's okay that it's a different value. After you complete the notes, please go to your Chapter 2 workbook and complete 4.1 and 4.2 homework. And we're going to look at problem numbers 1 through 7. Okay, problem numbers 1 through 7. Good luck.